Mac 1105, Chapter 3, Section 5, Part 2 on functions. First thing it talks about towards the end of the section is step functions, or some textbooks will call them greatest integer functions. They're denoted by this INTX, meaning greatest integer. Some textbooks, the old textbooks, use double brackets in case it's the same thing. What happens with greatest integer is that, remember, the definition of an integer is a whole number. So there are no fractions, there are no decimals in between here. So if I stick a 1 in here, I get 1 for y. That means I plot the point 1, 1. Well, everything is going to stay 1 at y until I hit 2. So you have what you call a step there. We have an open point here because when I go 2, I'm going to get 2, and it jumps up. And every x in between here is going to be 2 until we hit 3. And then it jumps up. And everything, and the y is going to be 3, but everything is going to be 3 until we hit 4, and then it jumps up. Thus, the name step function. Because as you solve these, whatever integer you get stays that integer for y until you get to the next whole number for x. Then we come to what's called piecewise functions. What piecewise functions are is they are graphs, they are functions that take parts of different equations. Like for instance, this one here is example 3. And it says f of x is equal to negative 2x. I put the plus 0 there because I always want to remind myself that this isn't slope-intercept form. And this says for if x is less than 0. So what's happening here is if I want to graph this equation, I start with my y-intercept, which is 0. Because it's a negative 2 over 1 slope, I go down 2 and over 1. And here's the line right there. But this tells me I can only use x's that are less than 0. So the x's that are less than 0 are on this side. So that means I've got to take all of this part of the line out completely. And because it's just less than 0, I've got to make this an open point because I'm not using it there. Next part of the graph says square root of x if x is greater than or equal to 0. So what happens here is, if we put 0 in the square root, we get 0. So we're right here. From the previous section, we should know that the graph for the square root of x does a 1, 1, which puts this point here. And then it does a 2, 4, which puts this right here. So it's really, it looks something like this. Mine's kind of not spaced out very well. Let me space that out a little better. So it's about right here. So there's the part of graph. Now see, piecewise function means you're going to use a piece of a graph, of a function. So in the negative 2x plus 0, which was this straight line coming here, we can only use x's that are less than 0, which means we could only use this part of the line. For the square root of x, it's x greater than or equal to 0. So we can use the whole thing, because that is the whole graph of the square root of x. In the example 4, we have another piecewise function, and what I've done here is I'm doing one piece in red, another piece in green, and another piece in blue. So the piece in red says that it's negative 2x plus 1 if negative 3 is less than or equal to x, which is less than 1. So what happens here is that first of all, I'm going to draw the line and I'm going to take away what we're not using. So if the line is negative 2x plus 1, then here's my y-intercept here. I'm coming down 2 and over 1, so here's my other point. So if I draw this line, then I've got this line that comes right like this. That's if I was using the whole line. But this says I can only use -3. So on my graph, here's -3. And if I follow this up for -3, puts me about right here. So I can't use any of this because I can only start at -3. And I'm going to 1, but I can't use 1. So if I come up here and follow this, I've got an open point here, which means I'm not using any part of this graph right here. And I'm just going to go ahead and put that there. So there's the only part of that graph I'm using, because it's from -3, which I'm using, to, oh, shoot, I'm going to 1. Shoot, sorry, my mistake. So I'm coming here. So I'm coming this far down. As I'm going from -3 to 1. So here's -3, here's 1, so I'm only here. So that's the only part of that graph I'm using. If I come to the second part, if you look at it, it says it's 2 if x is 1. Well, this is really an ordered pair. So if I'm at 1, I'm at 2, and I'm just putting a point here, because that's all it is a point. 2 if x is 1. So that's the ordered pair, 1, 2. Last part of the graph deals with the square graph, and it's if it's greater than 1. Well, if we know the square graph does something like this on both sides. But we have to be greater than 1, so we're not using anything that's less than 1. And we're going to have an open point here at 1 because we can't use 1. So there's our graph. If you look in the textbook, theirs is much better. You can see it there. It's much more organized. But the thing about it is you've got to graph one piece at a time using the x's that they tell you to use. The red line, which is -2x plus 1, we could only use -3 to 1. And this needs to be connected here. Okay. In terms of the green, it's a point. It's 2 if x equals 1. So we plotted the point 2, 1. In terms of the blue, it's x squared. Well, if you know your library of functions, a square graph goes here and here. Of course, we used all these x's, so then we can only use these. Make sure you understand in a piecewise function, none of your x's will be repeated because of your definition of a function. And the definition of a function says x's can't be repeated. So once I use an x in the graph, I can't use it again. That's the reason we have an open point here and an open point here.